Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the longest carbon chain containing the principal characteristic group, carboxylic acid, and the maximum number of substituents. The molecule has a carboxylic acid, -CO, at one end. Counting the main chain, starting from the carbonyl carbon of CO as C1, we trace the longest chain that also incorporates the terminal alkyne. The main chain contains 12 carbons total, ending in a terminal triple bond, C11C12, making it a dodec 11 enoic acid. Moving on to the next step. Identify the parent chain name. The 12-carbon chain with a terminal alkyne at C11, C12 and a carboxylic acid at C1 gives the base name, dodec 11 enoic acid. Moving on to the next step. Identify and number the substituents. There are 6 ethynyl groups, -CCH, attached to the main chain. Looking at the structure, these are located at carbons 4, 5, 6, 7, 8, and 9. And for the final step, verify the numbering gives substituents the lowest possible locants. With CO at C1, fixed as the principal characteristic group, the 6 ethynyl groups at C4, C9 and the chain triple bond at C11 is consistent with lowest locant assignment. Construct the full IUPAC name. 6 ethynyl substituents at positions 4, 5, 6, 7, 8, 9 on a dodec 11 enoic acid backbone. 4, 5, 6, 7, 8, 9 hexatenyl dodec 11 enoic acid. The prefix hexa indicates 6 ethynyl groups. Ethynyl is the CCH substituent name. Dodec indicates 12 carbons in the main chain. 11 YN locates the triple bond in the main chain at C11. C12 OIC acid indicates the carboxylic acid terminus. Therefore, the correct answer is 4, 5, 6, 7, 8, 9 hexatenyl dodec 11 enoic acid. The correct answer is shown on screen.